Today we will discuss a very important agenda in GATE examination, that is a chapter of calculus. Now this is not something new for us. We have already discussed this particular area of concern in our lower standards also. We have discussed in this chapter in the first year of engineering also, and this forms the basics of any mathematical fundamental, and that is why here again we are studying the fundamentals of calculus, right? So what are we going to study? Let us first define the syllabus which GATE has defined. Now if you talk about GATE examination for the last 10 years paper, if you see, you will find that the weightage of this chapter is somewhere around 5 to 6 marks. That's a very big weightage in the GATE examination, directly or indirectly, right? So there are three major sections, if I will say, in fact four major sections sometimes. Number one, linear equations or linear algebra, not linear equations but linear algebra, which contains matrices. Number two, probability distributions or fundamental of probability, and number three is calculus, question based on calculus. Fourth, I told for electronics is electrical, mechanical and civil students, which was on differential equations also. For computer students, that is not important as such, right? So we'll define the syllabus. First of all, we'll say what all things we'll study. We'll start with the fundamental of limits. In order to define calculus, we'll talk about limits. We will also talk about continuity and differentiability. We may also discuss about, third we'll be talking about mean value theorems. This chapter basically contains a lot of subheadings. We'll discuss one by one and I'll tell you while I'll be teaching you which are the important ones and which are the ones which we just need to understand the formulas and all those types of stuff, right? Fourth, we'll be talking about differentiation, question based on differentiation and its applications, important. We'll talk about maximum minimum. We'll talk about forming an equation of a normal and a tangent. Then we'll talk about integrations or definite integrations, examples of it and all those types of stuff. And finally we'll be talking about in this chapter, that is vector calculus. For some of the branches, vector calculus can be omitted. You can refer the syllabus book. If vector calculus is not in your syllabus, you may omit that particular part. But yes, there are a couple of questions which are asked in especially mechanical, electronics branches of engineering, right? So let's start with the very first heading, that is limits. Now what are limits? Let us understand this particular thing. See, as the name suggests, limit means to restrict. Sometimes there are certain places in practical world where it is very difficult to find the exact values sometimes. So what we do is we normally find the limits. So if I see, for example, let's say there is a curve, right? It is very much evident. Let's say you want the value of this curve at this point, let's say x equals to a, right? I'm just explaining you what is basically limits, and that is fx, right? Now you are not able to find the value at this particular point, but you are able to find the value just on the left hand side of this point and just on the right hand side of this point, right? And you say that are these two are giving you the same value. Then you can say, if they are giving you the same value, then you can say that the limit is existing at this particular point. We can say that limit is existing at that particular point, right? Now what do we mean by this thing? So we have defined two new terms now. One is called as left hand limit, and the next one we are talking about right hand limit. So first let us talk about left hand limit. What I'm trying to say is, for limit I use LT or LIM. This is a terminology which you can see. X is tending towards a of fx, right? Now this is how we represent the limits basically. Now if I'm talking about left hand limit, I will say it is a minus, right? I'm talking about it is a minus, right? So what I'm trying to say is, he is telling you is, so this can be basically written as limit h tends to 0 f of a minus h. Now what is h? H is basically a very infinitely small value, which we are basically saying it is tending towards 0. It's a small element which is almost tending towards 0, but it is tending towards from the left hand side, so it will be calling as the left hand limit. If we would tend towards the right hand side, we will call it the right hand limit, right? And similarly, when you talk about the right hand limit, let us talk about right hand limit. Similarly, when I talk about right hand limit, so limit x tends to, let's say, a. If I talk it from right hand, I will say plus of fx will be nothing but limit h tends to 0 f of a plus h, right? So as I said in the earlier diagram, that the for limit to exist, so here you are saying it is RHL and here you are saying it is LHL. So if the right hand limit is equal to the left hand limit, so condition, we can say, we'll say condition for limit to exist, condition for limit to exist is your LHL, your left hand limit, should be equal to your RHL, or will be called as the right hand limit. Or you can say mathematically, limit x tends to a minus fx should be equal to limit x tends to a plus fx. If this is true, then we can say limit exists at point x equals to a. Now you have to understand this particular thing. In theoretical concepts or in theoretical papers, normally many times you will find questions to prove that whether the limit exists here or not, or something like this, right? So in those cases it will be very much handy for you, right? If I take an example for this, for example, let's say check whether the whether limit exists for if x is equals to 1 upon 1 plus 2 raised to x, let's say, at x equals to 0, at x equals to 0, right? Now we have to check whether the limit is existing or not for this particular thing. So what we will say is, let us say For existence, we know that left hand limit should be equal to the right hand limit. So let us say limit x tends to 0 minus, because a value is 0 now, right, of fx is nothing but, can I say it is limit h tends to 0 f of 0 minus h, or you can say it is limit h tends to 0. You can say this is, we are calculating the LHL, or the left hand limit, is nothing but 1 upon 1 plus 2 raised to 0 minus h, or I can say it is limit h tends to 0 1 upon 1 plus 2 to the power minus h. Now when I apply the limits, this term will become 2 raised to minus 2 raised to, you can in fact say this is nothing but limit h tends to 0 if you want to simplify it, 1 upon 2 raised to h. Now this 2 raised to h, this 2 raised to h will become 2 raised to 0, that is 1. So this term will become 1. So this is nothing but 1 by 2, isn't it? Right? Okay. Now similarly, let us find out RHL. For RHL, we'll say limit x tends to 0 plus f of x is nothing but limit h tends to 0 f of 0 plus h. So it is limit h tends to 0 1 upon 1 plus 2 raised to 0 plus h, and if I substitute the limit here, you will get what? 2 raised to 0 will be 1, 1 upon 1 plus 1 will become 1 by 2 only. So we can say that LHL is equal to RHL, hence limit exists. Hence limit exists. Clear? So this is how sometimes question can be asked to justify this particular thing. Clear? Now we have certain things about limits. How questions in GATE are asked are basically based on some formulas, right? They are based on certain formulas. We have some standard formulas, right? What are those standard formulas? Before we move on to this particular area, there are certain standard results. What are those standard results? Let us put it down. Some standard result or limits. Some standard results or limits. Okay. First one, limit x tends to 0. The very famous one, sin x upon x. How much it is? 1. Second, limit x tends to infinity. 1 plus 1 by x to the power x is given to you as e. Third, limit x tends to 0. 1 to the power 1 by x, that is also e. See, what we have done in the 2 and 3 are the same. If you replace 1 by x, basically it's going to be the same thing, right? What is the fourth one? You can also say limit x tends to 0, e raised to x minus 1 upon x is equals to 1. I'm writing some results here also. Fifth, we are saying limit x tends to e, x raised to n minus a raised to n upon x minus a is n a raised to n minus 1. Similarly, limit x raised to, let's say, a, x raised to n minus a raised to n upon x raised to m minus a raised to m. This is basically the corollary of it. It is basically nothing but n by m a raised to n minus m, right? Then you can have many of this kind. For example, if I find a corollary from second, right? If I say limit x tends to infinity 1 plus ax to the power x will become e raised to a. A can be negative also. E can be minus 1, e can be 2, whatever, you know. So this is a corollary which you can derive. So you have to understand this particular thing and get the answer. Getting my point? Right? Then very simple phenomena like limit x tends to 0, 10x upon x can be written as 1. Right? One more standard result which you can use is limit x tends to 0, fx to the power gx. Function of function can be given as e to the power limit x tends to 0 gx into fx minus 1. So that is another one important result which you can use n number of times, right? So these are some standard results which are handy for us, which will be useful for us in fact, right? Apart from that, we will also discuss something called as, see, most of these standard results have come from something called as, we have known is L'Hopital rule. So in some books you will find it L'Hopital rule or L'Hospital rule or whatever, it is the same story, right? Whenever see, when we can use L'Hospital rule, it's very important to understand L'Hopital rule or the L'Hospital rule. Whenever we can use for limits where we have indeterminate forms. What are indeterminate forms? Indeterminate forms. Indeterminate forms are forms which we cannot solve. Some limits where you can find indeterminate form. For example, forms like 0 by 0, infinity by infinity. You cannot apply the limits. It will become infinity by infinity, 0 into infinity, or 0 to the power 0, or infinity to the power 0, or infinity minus infinity. These are basically 6 forms of indeterminate form, right? So L'Hopital is only applicable to this form. L'Hospital or L'Hopital is only applicable, you can put it as a note, to these indeterminate forms, to these indeterminate forms, right? So you have to be very very careful in this particular regards. What about these cases then? These cases first need to be converted to 0 by 0 or infinity by infinity, and then can be used for L'Hopital rule, right? So we'll understand some examples before we get into this particular thing, right? Okay, let us take a couple of examples from GATE paper itself. There was a very simple question in GATE 2010. GATE 2010. Let us discuss that question. The question was something like, the limit x tends to 0, sine of 2 by 3x upon x is, your options were 2 by 3, 1, 3 by 2, and infinity. Now, can you resemble this with some of the standard result? Yes, we can. We can say that, sir, it is of the form sin x upon x, or we can convert into sin x upon x. So limit sine of theta upon theta. So we have to do a simultaneous multiplication in the numerator also. Now if I see this particular part, what is this? So standard result, if x is 0, 2 by 3 x will also be 0, right? So don't say, sir, what will be 2 by 3 x now? Don't say that this needs to be changed. You can change it. If x is tending towards 0, any multiplicating factor will also become 0 only, right? So you can say this is nothing but 1 into 2 by 3, or I can say 2 by 3. So your answer will become first option, right? The very standard questions which you can see, right? Once you understand the formula, the fundamental, it becomes very easy for us to understand. Let us take another example from GATE 2008. Question was the value of limit x tends to 8 x to the power 1 by 3 minus 2 upon x minus 8 is. So I'll give you the options. In fact, the options were something like 1 by 16, 1 by 12, 1 by 8, and 1 by 4. So now when you talk about limit, so if I apply the limits, if I put x tends to 8, it will become 0 by 0 form. So applying limit directly, we get 0 by 0 form. So we can apply what? Yes, we can apply L'Hospital rule. So what we can say, what is L'Hospital rule? What is L'Hospital rule? L'Hospital rule says differentiate. See, for example, if I say limit x tends to a fx upon gx, where if I put x tends to a, then it is becoming 0 by 0 form, right? So let me explain you here. What is L'Hospital saying? If there is a limit fx upon gx which is of the form 0 by 0 or infinite, then this can be written as limit x tends to a fx upon gx is equals to limit x tends to a f dash of x upon g dash of x. That is what is the fundamental. You have to differentiate the numerator separately and differentiate the denominator separately, right? So in the above case, what will you do? In our question, where the question was limit x tends to 8 x raised to 1 by 3 minus 2 upon x minus 8. So what I will say is I'll differentiate, because I can see there is a 0 by 0 form. 0 by 0 form when we apply the on applying limit. So if I use L'Hospital, it will become limit x tends to 8. We have to differentiate the numerator separately and differentiate the denominator separately. So if you have differentiated the numerator, it will become 1 by 3 x to the power n x to the power n minus 1, right, upon 1. So this will come out to be limit x tends to 8 1 by 3 x raised to minus 2 by 3, right? Now if I substitute the limits now, we'll get 1 by 3, 8 raised to minus 2 by 3, or you can say it is 1 by 3. 8 can be written as 2 cube, 2 cube to the power minus 2 by 3. I'm just simplifying it, you can directly write it down. I'm just solving it so that you don't have any confusion. This 3 and this 3 will get cancels out. This 3 and this 3 can cancels out, so it will become 2 to the power minus 2. So the answer would become 1 by 3 into 1 by 2, which is, sorry, 1 by 4. 2 square will become 4. So it is 1 by 12. Right? So we can take the answer as 1 by 12. Clear? So this is how it will look like. Right? So you can see option B is your correct answer. Option B is your correct answer. Clear? So you can find infinite amount of questions on these particular fundamentals now. I mean, we can have a lot of discussion on this. There are a lot of questions based on this particular thing, right? Um, let us go through one more, which came in computer science 2010. Let us discuss that question also. One more question from 2010. The question was limit n tends to infinity, 1 minus 1 by n to the power 2n. Now, the options were 0, e raised to minus 2, e raised to minus half, and e raised to 0. You can say e raised to 0 is basically 1, right? So the options sometimes gives you a lot of, see, now when the gate has changed its pattern to numerical data entry questions where you don't have options, though there is no negative marking there, but you don't have options, so that becomes sometimes difficult to understand where to start with. Here the options are shouting at you and telling you that you have to use a limit standard result which is connected to E, and which you can see in a standard result. We have a standard result similar to this. Can you identify that? Isn't it or not? Limit n tends to infinity. We have a standard result. What was the standard result? 1 plus 1 by x raised to x is nothing but E, isn't it? We have the standard result, right? This is a standard result. Standard result. Now, can you think that this is very similar to what we have been given? Why I thought of this is because the options had e raised to minus 2, e raised to minus 1 by 2, e raised to 0, and so on, right? So in a paper also, options are going to help you a lot. In any damn paper you will go, you will find that the options can let you think. But now GATE has become very smart. Why they have not given negative marking for those numerical data entry sort of questions is because of this reason. Because now you don't have brain. You know, options are not giving you brain. You have to apply your own brain now, right? So let us go to this question. Can you see the resemblance now? Yes. Can I write the question as something like limit n tends to infinity 1 minus 1 by n. Now this is not x, 1 by n raised to n square to the whole power, right? Now this is a standard result. What is this standard result? This is standard result as e raised to 1. No, there's a negative mark, right? So you have to say that this is nothing but e raised to minus 1, and that is the whole square. So it becomes very evidently very clear, it is e raised to minus 2. So in a single line you would have got the answer, correct?